Hey everybody, this is Larry. This is me doing week 4 of the weekly premium challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. Hopefully I haven't done it yet. I haven't done it yet. That is actually exciting. That doesn't happen often. So let's take a look. It is a hard problem, so hopefully it doesn't take that long either. We have 527, word abbreviation. Given an array of distinct strings, words, return the minimum possible abbreviations for every word. Okay. The following are the rules for a string abbreviation. The initial is the first character, and the number of characters in between following by the last character. So it's like, okay, right? If there are more than one word in sharing the same abbreviation, followed. Okay, so that increase the prefix of each of the abbreviation by 1. For example, then sequence will be it. Okay. Okay. That's interesting. I think the key part, there are a couple of key parts here. Is that I think first I want to sort by length. And the reason is because I think the fewer characters, then you I guess it doesn't matter actually, now that I think about it, but because it can only conflict with I mean, maybe we do anyway, just for fun, but it can only conflict with so I'm just returning real quick to see if this has to be mapped. Okay, so maybe I can sort it. It's not like this because it maps to this directly, right? Like God to God, internal to internal, etc. Okay, but yeah, we still yeah, because only the 2 words that have the same abbreviation, and 2 words have the same abbreviation only if they have the same number of characters, right? Because for example, A5A is not the same as A6A, and there's no way for them to, you know, match, right? So okay. I think the way that I mean, there are probably a couple of ways to do it, and I think the probable clean way is to just put in a try. And yeah, okay. I was thinking about doing some hacky things, but I think putting in a try makes sense, because then now for each word, you can just see where it where the abbreviation is, right? Of course, you have to be a little bit careful with the try, because for this one, the uniqueness is not just the prefix, but also the last character. But that should be okay. Yeah. Does each word have at least 2 lengths? Yeah, that's what I was checking just to make sure. And yeah, we just have to be a little bit careful, but I think we should be good. So let's construct a node. Self.edges, and then that's it, right? And then now we go forward in words. We can say we just put it into the node, right? I do want to change it up a little bit. How do I want to write this? I mean, there are a couple of ways you could do it as long as you're consistent. And the way that I want to write it is just, yeah, for C in word, but not word, right? Because we want to actually skip the last character, and then maybe just use the last character in the beginning, right? And the reason is because then now, for example, for A4F, you just move F to the front, because in a way you just want, like, it's similar to a hashing algorithm in that you just want things to not match unless the 2 prefix matches, right? And then now after that, so then maybe we have oops. And then this is just right now very standard prefix try stuff, right? So if C not in current dot edges, maybe I want to count actually. Oh, I guess I could just do current is equal, see, and then current dot count 1, and the count here just allows us to keep track of the entire thing. And if a word has a count that has 2, then I just have to keep going until it is uniquely identified, right? And because every word is unique, at worst it just traverses through the entire word, and that's it, right? And this is actually pretty simple to set up, and I think we are mostly done. Maybe answer for word in words again, right? Maybe we have to traverse the same way. Okay, right? So maybe we don't write it this way yet. We go current dot edges of C, is the last character for the first one, and then because we know that, keep in mind that we already constructed the tree, right? So we know that these things will exist. So then now we skip the first 2, and then now while current dot count is greater than 1, that means there are dupes. Current is equal to current dot edge of word sub I guess. Yeah, I is equal to 1, right? And it shouldn't go out of bounds, though. If it does, it's a good smell, because this shouldn't go out of bounds, because in the variant that when you go through all the letters, this should be exactly 1, right? And that should be mostly it. Yeah, and we have to set up the answer real quick. So maybe the right. So then we just do r.append word sub 0. Every time we can move an edge, we do and then of course we have to increment by 1, and then we add the last word. Kind of. I think one thing I just forgot about the number. That's what I meant. So then now, yeah. So r.append, and maybe I'm off by 1, but something like length of word minus I or something like that. And the reason why I'm not thinking through it right now is because it's easy to see when we print out the thing. So I think maybe we just run it real quick. Did I mess this up? What is the word? I mean, the environment should be that, you know, we create everything here, right? Current is equal to root we go to E, right? Oh, okay. C not in I mean, it should be created. Huh. I mean, it is possible that I made some silly mistakes, so yeah. Yeah. I think this creates a list, that's why. And because this takes a character, but we created a list of 1 string element, and that's why. Okay, so there you go. Now that at least that part was resolved. Very easy to make mistake for me anyway. Okay, so then here, oh well, this is also easier to solve, at least directly. All right. Yeah, so we're off by 1, as you can see, so that's fine, right? So then now maybe this is I minus 1. It's still wrong because we don't miss stuff like God or whatever. But okay, so then now maybe we just put a stressful case. Extra is equal to this thing, right? If extra is equal to 0, then we just kind of ignore it. So that means that if extra is equal to 1, then we just append the actual letter. Else, if extra is greater than 1, then we append the length of the string, right? Okay, so that looks okay, but apparently we're wrong here. Oh, so basically it does the first 2 characters. It is unique. Did I mess something up? Oh, I'm dumb. I mean, That's annoying. This is technically okay. I mean, I know why, but I'm trying to think through how to work it out. But basically, because we use the same try for all the different lengths of words. AA is a prefix of AAA, so then the count at AA is 2, and that's why this is, I don't know, giving some funky stuff. The easy way, or the immediate way, I don't know if it's easy, off my head is just to have a tree for every length. Maybe that's fine, right? Maybe that's the way to do it. You probably could be a little bit smarter, but today I don't feel so smart. So let's just do. We just use a default dictionary, lambda of a node, right? So then now we just do length of word, and here as well, of course. And I think this should be good. Yeah. Still very awkward, of course, but let me give it YOLO submit. Hopefully it's right. And yes, not too fast, but good enough. I think there are other, because yeah, there are probably better things that you can do, but I think this is fine. This is linear in every way, I think, because we look at each count. I mean, I guess technically this is a little bit awkward because maybe this is the only part where it creates another string, but that's fine. Otherwise, this is linear because for every character we just make one edge, right? So this should be relatively fast. It is a hash table lookup, so I guess that does, has way bad memory locality and stuff like that. But I'm not going to worry that much about it. And you can, and this part is the only part that's kind of n square because this is a lazy operation. I don't know. I mean, you could probably take them. The way is probably just to like write them out, but I'm too lazy to do that. So that's all I'm gonna have for this one, though. Let me know what you think. Thanks for watching. So the idea is just, yeah, putting everything in a try, and then and in a different try, depending on the length, and then at each node count how many things there are. And once you count the number of things that there are, if it has more than one of them, then there's a dupe, and you have to kind of tie break longer along the way. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. I like this one. It's a fun problem. And yeah, stay good. Stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.